Okay, I'm going to call this one bonus number one because this word problem kind of goes into um, a little bit more. There's a little bit more to this word problem. So let me give you an example, or let me read it and we'll just go over it. Jake and Suki collect model airplanes. Suki has 4 fewer than twice as many model airplanes as Jake. Together, they have 14 models or model airplanes. How many models does each person have? Okay, so again, don't be too confused. Just go ahead and circle your important numbers. We have 4. We have twice. Twice would be 2. That's a number. And 14. Those are important numbers to remember. So even though this sounded a little bit weird, just go ahead and go through the steps. We're going to underline our keywords. 4 fewer, which fewer means less. So we're going to subtract. Twice as many. We know that there's some multiplication in there somewhere. And together they have 14. So that would kind of be like the total amount together. We want to then highlight the question. How many models does each person have? Okay, so now I'm going to set up and organize my information a little bit different than what I've been doing the last couple times. I have Jake, I have Suki, and I have my total amount. Jake, I don't know how many oops, I'm sorry. Let's go through the total amount. I'm getting ahead of myself. I apologize. Let's pull it back. Total amount, we usually can find all the time in a word problem unless you're looking for your total amount. How much is the total would be the question. But most of the time when you're doing equations, you already have a total. So together they have 14. 14 is my total amount. That one's always an easy, it's kind of a given. I was just so excited about the other ones. Let's put that number down there because that helps us at least know that we got something in the right place. Okay, so now Jake, we don't know how many he has. So I'm going to use M as my variable. It doesn't tell me how many Jake has. So M, we're not sure. Suki, though, has 4 fewer than 2 times as many as Jake. If Jake has M, Suki has 2 times M minus 4. And you're going, what? I don't understand. Okay, so when we read this, it's Jake and Suki, they're collecting the model airplanes. They have 14 together, 14 total. So we see that number 14 down there. Now, it tells us Suki has 4 fewer. So we're going to minus 4 somewhere in here. Then 2 times as many planes as Jake. If we're not sure how many Jake has and we're saying Jake has M, Suki has 2 times that amount minus 4. Because she has 4 fewer than 2 times as many, which means she doesn't quite have 2 times as much. But we're closer to that, and that's why it's worded the way it's worded. And this is how you're going to write it. The other thing we need to do is add that plus sign because we have to add Jake and Suki together to get our total amount. So now, when I go into my next screen, I'm going to rewrite it. Now I color coded it, so you could kind of see Jake is purple M, Suki is the green M, or 2M minus 4. I even put her into the parentheses because I wanted you to see that when we figure this all out, how we're going to understand who has what. So now look at my step number 1. Combine like terms. I don't have anything to distribute, but I do need to combine my like terms. I need to combine my M and my 2M. So even though I have parentheses and you would see the parentheses and go, I need to distribute. Well, there's nothing to distribute because nothing right here is next to the parentheses. I'm adding this together. I only put it in parentheses to show you that this little expression right here gives me Suki's planes or models. But right now to solve for M, I've got to add the 2 M's together to give me 3M. Then I bring everything else down. -4 equals 14. They were just coming along for the ride because I didn't have to do anything to them. I was just combining my like terms. My 1M plus my 2M right here gives me 3M. All right, so now we're going to go into those steps that we're familiar with. We have 3 times M minus 4. I'm working on the left side of the equation here. I can see that I have that -4 right here. So I need to do the inverse operation, which is a +4. I do that on both sides. That crosses out. I'm going to go ahead and bring down my 3m. 14 plus 4 equals 18. Now, 3 times m is multiplication. And so in order to get rid of that 3, to get my m by itself, to isolate that variable, I need to do the inverse. So I'm going to divide by 3. That cancels that 3 out. And 18 divided by 3 is going to give me 6. I bring down that m because of the fact that I didn't cancel that out. Now the question is how many planes do both of them have? I cannot just say m equals 6. What I need to do to figure it out is I've got to plug this 6 back into my equation. So remember how I color-coded them up here for you? M equals 6. So if I plug that 6 into here to be a purple, M that's purple equals 6, Jake is purple. So I know Jake has 6 models because of the fact that he's that beginning part of my equation, this whole equation right here. And then I have Suki, remember she was located here in the parentheses, so I need to just kind of do that little bit of work right here. 2 times m, or 6, is 12. Minus 4 is going to give me Suki's planes. So 12 minus 4, I believe, is 8. So here it is. Jake has 6 models because we know m equals 6 when we look up there. And Suki, who's in green, has 8 models because 2 times 6 is 12 minus 4 equals 8. And the other way you can say it is Suki has twice as many as Jake, but minus 4. 2 times 6 is 12, or twice of 6 is 12, but 4 fewer than that is 8. So your answer to this one is Jake has 6 models, Suki has 8 models. That's the answer to this. Sometimes when you color code them, it helps you see what exactly you're trying to do. So when you get your m equals 6, you've got to plug it back in to figure out who has what. Because there was no other way for us to figure it out, except for Jake. If it just said how many models does Jake has, we could have figured that one out because of this right here, because there's nothing to add to it, to the purple. But to the green, we had to do a little bit more to get her amount. Okay? And that's where we've used our first step. Step number 1, how exciting!